Welcome back. So we will analyze the motion of this block in the interval of dx, making fs constant. And if fs becomes constant, we can happily utilize this equation. Okay. So let's get started from here. Work done by spring force is equal to fs vector dot d vector. Okay. That comes out to be fs vector magnitude into d vector magnitude into cos phi. Now we can see here it is a modulus of fs vector. We can take it as fs, okay, into d is the displacement. Since the displacement is in x direction, we can call it as x into cos phi. Phi means angle between spring force and the displacement d. Okay, we can see here displacement is in left direction. It is moving from xi to xf, so displacement is in x direction, negative x direction. However, the spring force is acting towards positive x direction, so there is angle of 180 degree between these two vectors. That's why cos phi is equal to cos 180 degree, and that comes out to be minus fs into x. Cos 180 degree is equal to minus 1. So work done by spring force is equal to fs into x. Okay, where fs is nothing but magnitude of fs, x is nothing but magnitude of the displacement, and cos 180 is minus 1. Okay, from where will we get the value of fs spring force? From Hooke's law. Hooke's law says fs is equal to minus kx, but here fs is nothing but magnitude of fs. Okay, so we will take magnitude of minus kx, and that comes out to be k into x. Okay, now we are taking the displacement, we are taking the motion of this block in a displacement of dx, then only fs will be constant and we will be able to utilize this formula. So for dx displacement, let's consider the work done by the spring force is dws. Okay, therefore dws is equal to minus spring force into dx. Okay, so what is spring fs? Fs is nothing but minus kx dx. Let's delete these things. So, so it comes out to be dws. dws is nothing but infinitesimally small work done by spring force when the spring moves a distance of dx. Okay, now if we integrate both sides, we will be able to get total work done. So total work done by spring force will be equal to minus integration of kx dx from x initial to x final, and that comes out to be minus k x square by 2 x initial to x final. It is equal to minus 1 by 2 k x final square minus x initial square. So this is nothing but total work done. Total work done by spring force is equal to minus 1 by 2 k x final square minus x initial square, where x initial is the initial position of the spring or the block, whereas x final is the final position or final compression of the spring. This is the total work done equation that we get. Okay, now if we consider the x initial to be 0 and x final to be x, this equation comes as work done by spring force is equal to minus 1 by 2 k x square minus 0 square. That comes out to be work done by spring force is equal to minus half kx square. So this is nothing but a specialized work done by a spring force where we have assumed x initial to be 0 and x final to be x. But this is a more generalized form of work done by any spring. Okay, so let's proceed further in the next example.